right, we are in Arizona, outside of Phoenix, at Dan D'Agostino Master Audio Systems. This is a factory, it's a hacienda. It's a very cool looking place. And we're gonna go in. This is a celebration of a brand new product. It's also the 15th anniversary of D'Agostino, which is quite an achievement. And this is the Momentum Z. And you can see two giant toroidal transformers. Oh, this is a hot plate. I'm sorry, it's not an amplifier. No, it's an amplifier. I'm just joking. And then, as Dan is talking about it, let's go over and see what Dan has to say.
Don't try to sneak into your room like that. I know what you've got behind your back. Records. More new records.
You're going to hear effortless sound. There's never been sound like this, ever. I promise you, no one's ever had this. So it's going to be quite extraordinary.
You open a new gate.
Yes, it's a new thing. We're going to go through this in detail.
Okay.
And then look at your notes when we're done.
Before I leave, yes.
Yeah.
You can't leave unless everything's approved of, okay? These are people from all over the world who are here. Everybody who's anybody in this business, at least who sells D'Agostino.
And then they invited you.
And I got invited, so that's why I'm standing by myself. That's why I'm standing to the side. I'm not part of this. Mine's got a lightsaber built in there. Use the force.
He and I both have the same shame.
Oh, that's funny. I also have that too.
And then there's Gavin. He's the, I guess the...
Let's, as long as we're here, let's look around. This is big. Why don't you put your finger in there and see if anything happens? Oh, you would like to have one of these. You would like to hear one of these.
All right, everybody, we'll get going here. Thank you. Hopefully you all have a great night last night. And enjoyed dinner, got some sleep afterwards, so thank you for coming out again. So I'll give you a little bit of the agenda, what we're going to do, before Dan gives us all the high points on the Momentum Z. So we do a training with folks when they come out. Some of you have already been with us for those, so we're going to sort of do a version of that, but since there's so many of us, we're going to split it up. So we'll have 6 different stations going on. Start in the sound area in the back, then we'll have the Momentum Z area, we have the wave solder, we have Jesus building a Relentless preamp volume control to show you.
And then you'll be quizzed on it. And if you can't build the volume control after he shows you, then you'll be shown out the door.
So easy. Yeah. We don't have Dan involved in the trainings.
Right.
So then we'll go through our boards, how we kind of do our inspections, our quality control, just show you all the steps, and then the final one will be the test area in the back where we'll have a Momentum Z back there as well as a pair of 800s to show you kind of how we go through everything. So again, I appreciate you coming. We have some things to give you. The website is live right now, so the Momentum Z is on the website. So all the pictures you're taking, you can take any picture that you want. There's nothing that we hide here, so everything can be posted. Then we have, after we go through that, we'll have lunch. We have a taco truck rolling in. After lunch, we'll do a little bit. We'll be back here. We'll do a little presentation. I'll do on some core technologies, stuff that really makes us who we are. That's kind of core. That'll be a kind of abbreviated version. Will be a little tighter than I would normally do. Take you back to the hotel, rest a little bit, and then we'll be over at Dan and Petra's. We'll get you back over there, and then you'll get to hear the Momentum Z and the system. and we have barbecue coming in for that. We have a Manhattan bar. And so this is the first time that we are showing something and shipping it right afterwards. So it's sort of a new kind of setup for us and a product to market plan that you'll start to see as we go forward. That's way to do it with everything. So with that, I will pass it over to Dan. He's going to talk about the Momentum Z.
Well, 15 years ago we made the Momentum, the 300, and it was like a milestone for me as a designer because I used to work in big metal, you know, the Krell MRA. That was a big piece of metal. And, you know, it had its own foibles and problems because of its size. And then Petra and I talked about what we would do when we started this company. Remember, we started with nothing. So we had a clean sheet of paper, and Petra had worked with the Rob Report and luxury products. And she always said, we don't have anything in our industry that is a luxury-looking product. And that's how this design for the 300 came into being. And, you know, it included my son, Brett, who was involved with me, helping me draw this thing out. And it was a really kind of interesting time. Her and I and Brett went to see a show with a drawing on a piece of paper. And some people were interested, and some people say, yeah, show me when you have it. But we did get it done. And, you know, it was a product that I feel really closely to, and I never wanted to change the form factor and the size and the look of it. And then for our 15th anniversary here, when we looked at the amplifier as it was, we think that on the MXV we pushed that technology as far as we could. We really can't get more out of that amplifier than we're getting right now. So if I looked at it empirically and said, what are the shortcomings of this amplifier? There's very few, but it could have more power. And I can't get that with that technology in that box. So then we started to look. Well, you know about the pendulum, right? So when we did the pendulum, we start playing around with FET inputs. And the pendulum was the first product that used a FET input. So we liked what we got. Sonically, it was immediate product that we loved the sound of. As soon as we put it on, we sat back there with those Alexas, and wow, that's amazing sound. With no effort, it makes this sound. So we finished the pendulum, and then I was talking with Burhan and Yosef about what are we doing with this? We're limited on the pendulum because of the technology in the front end to 100 plus watts. Okay, so that we knew that when we went in. Then I started thinking, how are we getting more power? So if I look back into my engineering background, cascode the FETs, which people do. They did it a long time ago with the Toshiba, the old Toshiba FETs from the 80s, but that all got discontinued. Now we have this company that makes FETs for the military and for space exploration, and we use their FETs, and we're able to make real power with them. So once we did that, we made a board, and we listened to it in the Momentum, and it was an immediate improvement sonically. Really tactful. I mean, you felt the music, you felt into it, and there was an effortless. But also, you know, a lot of times when something sounds really musical, you lose some detail. And you'll notice there's amplifiers out there in the market that are super smooth and musical, but there's no detail. There's no real bass, no top, but it's musical. So I hate that sound, by the way. It makes me sleep. But anyhow, what this had was something unusual, was that it had this super musical warmth, but it also had extreme detail, extreme on the outer edge of almost too much, but just perfect. So we started playing with that. And then we started thinking about what can we do with the Momentum. So at Krell, I had a product called the FPB. It was a breakthrough product for us at Krell because it was the only product that was ever made in audio with a regulated output stage. So regulated output stage. So that's something special because you don't need great big capacitors. All you need is a really good regulator. But there was something about that amplifier that I really liked and something about it that I didn't. And what I didn't like was a darkness in it. It had great bottom end, but oftentimes it shaded on being too aggressive and kind of dark at the same time. And I couldn't put my finger on what that was. So one day at Krell, before I left, I actually took that circuitry, took the regulator out and listened to it, and a lot of that went away. So I said, it's the regulator. So then I start studying the regulator. And so I said, it would be great to regulate that amplifier, but the regulator always makes it sound worse. And I found out what the problem was, is that if you build the regulator with the same parts you build the output stage with, it's exactly the same speed as the output. It actually has to be 2 to 3, maybe even 10 times faster than the output stage in order for it to work. And that was the key. So once we started experimenting with some devices, we were able to get that performance. The regulator is way faster than the amplifier. And when you put the two things together, there is a magic that you can't get. There's such advantages to regulated output transistors. They always are operating exactly the same. What else does it give us? The regulator is the safeguard of the amplifier. So in the audio circuitry, there's absolutely no protection. No relays, no input capacitors, nothing. Just DC coupled amplifier all the way out with nothing in front of it. So no protection relay, no anything. It's directly hooked up to the speaker. So how do you protect it? Well, the regulator is smart. It's got two phases. It's got a plus and a minus, and then it's got a third monitor. So when you look at the amplifiers operating, you're going to see 3 LEDs turning on, testing each other, and then reporting to a central controller. That regulator is everything. It senses how much current the amplifier does. It senses if you short the output. It senses if there's something wrong, and it shuts the amp off immediately, way faster than any protection device. But the beauty, it's not in the audio chain. It has nothing to do with the audio. It only has to do with a precise measurement of current and voltage. And when the amplifier gets out of that perspective where it's safe, it shuts off. So that's the first time you're going to hear an amplifier like that, because nobody has done what we did with the regulator before. So this is a special breakthrough. But I will tell you, when you listen to it, even at low levels, you're going to hear what that regulator is doing. And I was shocked when I heard it. It has a performance envelope that's different than anything that I've ever built and ever heard. So when you even listen to it at low levels, it's going to make you think you're playing it loud. You hear the low bass notes, you hear impact, you hear width, you hear highs, you hear space. It's all there at low levels. I mean low. And that's something that none of the amplifiers on the market can do, including ours. This is new technology. It's a new thing that we're doing. And I think that amplifier is a beautiful looking amplifier. It doesn't really change what the original Momentum was. It looks like a dressed up, classier, more expensive version of it. Like, you know, buying carbon fiber for your Ferrari, you know? It's kind of like that look. You still have the form factor. It still makes you think that it can go anywhere. But unlike the other amplifiers, it's a monster. I mean, it puts out over 2 times the current as a 400. And a 400 puts out a lot of current. This is way different. And it does it completely seamless. Okay, so let's talk about the FETs on the input. So what's the downside of using those FETs? So we use them in a special cascode circuit. Downside is low impedance. So if you measure it, it's really low. In fact, if you put it on a regular distortion analyzer doesn't like it because it's really low. So we started to think, what is the bad part about that. So we started to think before we actually built one, what happens if somebody hooks up a tube preamp, or somebody puts, the guys who like to put their digital device, their DAC, and drive the amplifier direct. Does it work? Of course it will work. Of course it will. You just won't get the performance that it can do. So what we did is we put 2 sections in the input. We have an input that's a 1 megohm input impedance, which is really high, and that will work with anything. And then we have a switch. If you throw that switch, it's down in the low hundreds, or lower, depending on depending on our measurement. But what if you made a preamp that was tuned in to that particular low impedance input? So we did that. So you'll be able to buy a plug-in for your C2. There's an upgrade that has that. The C2 at my house has that low impedance drive. So you remember back at Krell, you remember Cast? Mm-hmm. You know what Cast really did? Was it dropped the noise floor. Mm-hmm. But it made everybody in the cable business hate us. Everybody hated us because we had a proprietary hookup. And I remember I wanted to use the telephone cable, you know, that J45. I wanted to use that for Cast because it would work fine. And you could run half a mile of it. So there goes the cable business. But Bill and the other guys went nuts when I told them I wanted to use telephone wire to hook up our audio signal. So we made a LEMO connector, which was a pain in the ass to build. And nobody could put a cable on it. So this is that only in the voltage domain. So when you have that output stage and this input stage, you're going to get that same cloaking effect, the silent background and the dynamic contrast that this kind of input with the right output stage of a preamp can make is thrilling. So by the way, if you took an iPhone, you could hook it up to that 100 ohm input, it plays it. So it's not unfriendly. Bill was really worried. You can't make it unfriendly. I remember the phone conversation. What if no one can play it? What if it breaks something? I said it won't. But when we did it, it actually, I said it wouldn't, and I was right. You can play it with anything. But if you want the full frequency response, you have to play it with the right kind of output stage. So not to say that any of our preamps won't drive it. It drives really good. But with this special output stage, it's a lot better. It's way better. In fact, the cables at my house were made by Transparent for that input impedance. So it's a special cable, which you guys who sell Transparent can do. You guys who don't, I'm sorry. But you can tell whoever you buy cables from what the input impedance is of the amp, and if they could accommodate it. But anyhow, all those things are put into play here. So when I brought these amplifiers home and listened to them, I said, wow, this is a different sound. But then I said, is it better? Well, I got to tell you, it's a lot better. You know, I've always sweated, and when I had the Momentums at home, I had the MXVs at home, and I bought the first Relentless home, I'm like going, wow, 6 guys to get them in my house, and we're going to hook them up, and God, I hope that sounds better than the Momentum. Well, it did. So that was good. These are much lighter and easier to move around, but I think when you hear them, you're going to be thrilled. I do. So the fit and finish is exemplary. As you can see, the top cover comes off with 2 screws. You can slide it back. It's got a RJ45 you can plug into your computer. The amplifier will diagnose itself. So if something goes wrong, it'll tell you what's wrong. We did a very unusual meter. It's got an analog meter movement because everybody kind of likes that. It's watch-like. But the background is digital. It's not a piece of plastic. It's a digital media that makes the background and the numbers and the name and all that stuff. And also, when something's wrong, that display will kind of tell you something's going on. So that's another different, it's a different take. But I also, things on some of the stuff with the Momentum, I always wasn't sure about the angle of the lens and stuff, so I lowered it down a little bit, and so that there actually is no angle of that amplifier that doesn't look good. So that was important. And we also like to build the amplifier top side up, and this amplifier is built that way. The Momentum was built with itself with the top down, and we built it from the inside on the bottom, and then everything was upside down. So we built it in a conventional way. So anyhow, that's the story of that amplifier. Do you want to step in here, Bill, or you guys want to ask me some questions? No, but what?
You were saying that this amplifier is quite a bit better than outdoor Momentum. How is it relative to the Relentless?
Well, it's a different sound than the Relentless, and the Relentless is way more powerful. But this amplifier is about 550 into 8 and doubles all the way down to 2. The difference between this and any amplifier that we've ever made is that we depend on high voltage, so that as you go down in impedance, the amplifier will still make its spec, but the voltage drops as you go down. So if we said it's a 1600 watt amplifier, it probably is more than that. So that when we get down to 2 ohms, it still puts out its specification, but the voltage that it started with is going down as we're doing it. And that's what our unregulated amplifier does. It's the only way. So everything out there that is unregulated does that. So being that this is regulated, let's say you have 50 volts at 8, at 2 ohms, you still have 50 volts, 49.8 or something. It doesn't change at all. So think about that when you're playing a speaker, what that actually does. So if you take the sliding curve, for instance, of Wilson, the low bass frequencies go down below 2 ohms sometimes. This amplifier doesn't care about that. Doesn't even know. Voltage to the output devices is the same. It doesn't know that it's actually happening. Nothing changed. So there's no bounce in the amplifier. It's just there. And you'll hear that when you come to my house and you hear the bass response and how it handles that and how the speaker acts with that amplifier on it is different. And it's like equivalent. It gives you an equivalent bass slam like a 1600 in that little package. So you'll hear that. And there's going to be trickle down and trickle up technologies that are going to go forward. There will be stuff coming for the Relentless. There will be new products coming out very shortly. There's a new progression line coming out. And so we're working on a lot of things. There's preamp stuff coming. This is going to be a big year for you guys. I'm not sure. We have not decided if there's going to be a stereo version of that amplifier. We could make it, but we're not sure. So anyhow, any other questions about the amplifier?
Can't wait to hear it. Yeah, the basic input will work with anything, but we could take it up yet another level, and that's what this input is all about.
So how about taking it, putting another 6 dBs, a quieting noise factor on it, more dynamic contrast in the signal, everything linked together so the 2 gain stages in the amplifier and the preamp are mated. I mean, there's a lot of current flow at 100 ohms from a preamp. There's nothing at a mega. So I think that's it.
Robert,
oh yeah.
I have to ask a question. You talk about the Momentum C2 preamp. Does it then become a Momentum Z?
Yes, it becomes a C2Z. Okay. And not for nothing, Z in engineering is impedance. So.
And that's an upgrade?
Yeah, it'll be an upgrade. Yeah. Bill didn't want me to say that, but I had to say it. I'm just a truthful guy. I'm an engineer and I walk around in my cloud and I don't think about marketing. I don't think about hurting customers' feelings or anything like that. Not that I want to, but I do things that sometimes does do exactly that. And that's not my game. My game is to make things. And right now, I'm doing stuff that I always wanted to do, and we're on to this new threshold of what can be done sonically. This is all about sound. I don't care about specs. I care about the sound. And if we do something that has magnificent specifications like that amplifier, and it sounds better, that's a winner. It's hard to beat that.
Thank you. Thank you.
All right, well, welcome. I'm going to start off by showing you the kind of the jig over here where we start. This is kind of where we test a lot of the boards for the 800s and the 1600s. These are the 1600 outputs. The input board is the same as the 800, exactly the same. The 1600's got the 6 large caps and of course the larger toroid transformer. The 800 only has four large caps. So there's 2 less. These are 100,000 microfarad caps. Let's see. The 800 has this board and then a half board here. It has a daughter board instead of a motherboard. The 1600 has the full set on both sides. We'll go over here. So once the testing is done on there, the initial testing, if it passes there, then it goes into the unit to be tested. And then of course we assemble it and test it here. And this is kind of what the finished product looks like. Once it's all put together, it's tested in phases.
And which amp is this?
This is the 800. This is Relentless 800. So we start with all the high and low voltages from the AC coming in, and we just kind of work our way back. So everything gets tested as it's being assembled. So you have this unit has, unlike that one, which has 1 large transformer, this one has 2 transformers that are stacked underneath this plate. Kind of hard to see, but there's two transformers in there. So we start with the AC circuit and work our way back through the rectifier. We check all that, and then we verify all the voltages on the main power board in the back. And then once all that's confirmed, then we start hooking up the outputs. And then we go through each output separately, and once those are right, then we start bolting it all together. So, and then once it's bolted all together, it goes on burn, which goes here. And then we basically run cables to it, and these cycle on and off about every 10 minutes. So we just figure out what the input's supposed to be, and we feed the input to it, and this thing cycles on and off every 10 minutes. We put these through 1,000-watt loads while they're here. And it's the same with these. These are all the inputs are slightly different because based on the product line. But these get a little more, because we want to drive 100 to 200 watts through this, through several intervals on and off. And then we turn it off and we let them go down to a complete cool down, and then we do the same thing over and over again. We repeat that process. So we've taken these up to 140 degrees Fahrenheit. Get them nice and toasty, and then we let them cool completely down to room temperature, and then we do it again. Over here, I can show you what we do as far as how we calibrate the meters.
You get a bad shock?
No.
No, it's good.
I'm good. You probably could if you didn't know what you're doing, but they're... Okay. Get this. Low input, we give it 25 watts or so, and then we just slowly increment it up to about 500 watts. Even though it's an 800 watt unit, we'll go 500, 800, back down to 5, 2. We just do it manually, and we check the TDS distortion to make sure distortion's within range. It's 100 watts, distortion's 0.006. So yeah, so we'll drive it all the way up to make sure that the signal stays exactly clean all the way through. There's no distortion. It performs exactly the way it's supposed to. 400 watts right there. So the signal is just perfectly clean all the way. And then we also, being that they're in pairs, we use the same thing to calibrate the meters to make sure the meters are exactly the same.
What are the power facilities for this whole operation? I mean, outside here?
We have commercial power brought in.
We should go look at that. Should we see that?
It's on the other side, yeah. I think it's all sealed, but you can see it.
Yeah.
You can see the panels outside. And I think at one time we actually increased the current here because there just wasn't enough.
Just one giant star graph for everything right there.
Yeah, yeah. These will draw. Of course, you can't see on this Variac, but these, if at 120, they draw about 3 amps apiece, just sitting idle. So you're going to draw 6 amps with just 2 units sitting there at 120.
So unit-to-unit amplifiers, how much variation is there when you get these?
Not a lot.
Not a lot.
No, because the resistors are like, what are they? Less than 1%, 0.5%, right? Yeah, so they're all really, really close. So if it's going to fall out, it does it pretty quick.
Yeah, that's what you pay for, right?
And you know exactly, yeah.
I would like to introduce to Momentum Z Ethernet stage. We have one interface for troubleshooting something. It is first time we put Ethernet input on the amplifiers. So I'm going to show what we did, what we need to use Ethernet stage. Right now we have one user interface. It is like a web page. You guys are able to access Momentum Z serial number .local, and then you guys will access this page. And then we have some check marks here, like a input stage voltage, regulator output stage voltage, controller voltage, and unit informations like bias, temperature, DC offset, and also we are able to see like a line voltage. And also we have digital screen, like a hybrid screen inside of the unit. So the meter is like we keep the classical meter from front of this, and then we use digital screen on the back. So when we put digital screen, we have to adjust brightness, and then we have to adjust like a dark mode something. We also adjust those at the Ethernet page.
This is Rob. He runs it. This is a highly tuned machine. I refer to it as like a drag car. Every little tiny thing makes a difference, and he is an actual racer. No, he drag races, so he is perfect to run this machine. Some of you have seen this, some of you have not, but I'm gonna let him just take over and give you a breakdown of what we do.
Right. The first thing I always ask is, do you guys know why it's called wave soldering?
Solder's using waves?
Close. What we are actually doing is we are generating inside here a static wave of molten solder. And so what we mean by static is it's flowing in two directions, but if you look closely at the very top of it, the solder is almost sitting perfectly still, and it's getting backflow in either direction. Really important, if the solder is going too fast against the board, it won't have time to penetrate the vias. If the solder is going too fast with the board, it stays with it too long and will have bridging. So the calibration of that wave is really, really critical in terms of getting the solder connections correct. And the process is 3 different steps. The first step happens in this part of the machine. This applies what's called flux to the circuit board. Typically when you hand solder, the flux is inside of the solder. Since our solder is already molten, we have to apply it here first. And the flux does two things. It modifies the viscosity of the molten solder, makes it more liquid so it will flow. And more importantly, it encapsulates the solder joint while it's molten so that it's not exposed to oxygen until it's cured. If it gets any kind of oxygen, you can actually see on top of here how fast, if you look, you'll see some little lines of oxidation forming the very instant it hits the room with oxygen. That really is not optimal for a good solder joint, and by encapsulating it with that flux during that, it keeps the air away from it until it solidifies. And I'm going to go ahead and close this when I get a whole bunch of fumes in here. So the whole process is, the cadence is set by the conveyor speed. That determines how long it's going to be getting flux sprayed onto it, how much time it's going to spend in the oven, and most importantly, how long it's going to be in contact with the wave, what's called the dwell time. So we typically will set the conveyor for the optimal dwell time, which right now we're about 2.5–3 seconds. And then based on that speed for the conveyor, we'll set the oven temperature to get the board up to the correct temperature, and set the flux sprayer to apply the correct amount of flux. We'll go ahead and put a board through here. And one of the things you'll notice when you look at this is that certain parts are not on it yet. This is a special tape called Kapton tape, which is amazingly enough will survive the wave solder process and stay in place. And the reason we do that is on this particular board, there's some connectors that have to be mounted on the back side. Obviously can't go through the wave. And we use some really great military grade FETs that are very temperature sensitive. And our decision was, instead of soldering at a lower temperature to accommodate the FETs, we would solder at a higher temperature to get that military grade soldering to it, and then our builders will put those last few parts on by hand.
Solder by hand too?
Yeah, absolutely. So everything you see on there that's taped, those are all parts that will be applied after the wave solder process.
This is not surface mount technology, right?
No, this is all through hole.
Some of our boards are surface mount. Not all, it just depends. And really, one of the best part about this machine is before we had it, we hand soldered every single board. Every single one was done by hand. And you know, a board like this takes a person an hour to solder. This is going to go through in about 3 minutes, and then we can just keep running them and running them and running them.
So much money you can lower the price of the amplifier. No.
They got to pay my salary.
We also have to pay for the machine.
So what's happening right now, there's you can't see it because the board's over it, but there's a photo sensor that it's crossing that is determining where the beginning of the board is and where the end of the board is. And that tells the rest of the machine where the board is in the process. So it knows, you'll hear in a second, the flux sprayer knows when to turn on, which it read the front of the scaffold. Once that board gets right over the fluxer, that will come back on and spray it. And typically I will not have the wave running full time. The reason is that the solder oxidizes and goes away really fast with turbulence. So in a normal production where I'm running boards through in a long conveyor, that wave will shut off until just about a second before the board hits it. The wave will come on, solder, and then turn back off to make the life of our solder last longer. Verifying that the oven did its job correctly. So I'm just taking the temperature of the board. We're going to be looking between 90 and 100 degrees top side of the board, or right at 91 degrees. And what you're seeing here, if you look closely, you'll actually see the solder coming through and soldering the top side. That process only happens if everything else ahead of it is perfect. Otherwise, you just get solder on the bottom. And we're seeing that smoke is a good indication that the flux survived the preheating and made it to the wave. If we didn't see any smoke right there, it would mean that either not enough flux was applied or that it burned off in the oven, and we'd get a less than quality solder joint. And another important factor is not so much how hot the board gets, but how quickly it gets hot and how quickly it cools down, what's called the ramp time. So we like to get the boards preheated in the room a day ahead of time, get them all up to 80 degrees. And then as it goes over this fan, we're kind of letting it kind of come back down nice and slow. It can take a lot of heat, just can't get hot too quick, can't get too cold too quick.
We each get one of these as a souvenir of our visit.
And what we look for when I take it off the wave before it goes through the rest of the inspection is, are the solder joints nice and shiny, which means that the flux was applied. If they're dull, it means that the air got to it before it was finished cooling. And so as long as we see that all the joints are nice and shiny, and we still want to see just a little bit of that residue of the flux left behind to let us know that it had enough to do the soldering. If it comes off and it's completely clean, there's a chance that it didn't have enough flux during the wave process.
So everything was lead-free when this company started, so they didn't have to go back and redo everything, right?
We actually, when I took this machine over, we switched back to leaded, which is all aerospace, all medical, all military is leaded.
It's legal to use leaded?
Absolutely, absolutely. There's a reason aerospace and medical all use leaded solder. It is the easiest to get right, and it's damn near impossible with lead-free. If there's a small error, you have to throw the board away. It's very hard to do what's called rework with lead-free. So in the interest of trying to hit those military specs, we put the machine back at a leaded solder.
So how long ago was it that you switched to leaded solder?
Shortly after I took over the machine and realized how bad it was.
I've been with the company almost 8 years now, and we've tried to use unleaded solder a couple of times, and we've encountered just so many issues that we've just decided at this point that leaded solder is the way to go. That's what works. Yeah, it's way more reliable.
And the other reasoning is, as he mentioned, is with the lead free solder, it's really hard to get what's called a class 3 board, which is the military and aerospace grade. A class 1 board would only need to be soldered on the back. Very easy to do leaded or lead free. A class 2 board, which would be like industrial, like something in a factory, a robot in an assembly factory, that requires, for that classification, for the bottom to be soldered, and all of the vias or holes have to be soldered to the top. For a military or aerospace grade board, a class 3 board, you must have full solder on the back, the via, and the top pads all have to be completely soldered, mainly for mechanical stability. Our amplifiers are subject to the heat.
Benefits of changing the quality of the board is more construction quality.
It's more of the board holding up.
The durability of it.
Yeah.
Every time you heat cycle a circuit board, it's wearing on that solder joint. We're also subjecting them to pretty good sound pressure vibrations. Typically, the speakers are in the same room, and so our boards are kind of taking a hard hit compared to an alarm clock you buy at Walmart that just sits on your nightstand at 70 degrees and never moves. One-sided soldering is more than efficient for that. So that was part of the reason why we decided to go back to the leaded solder is we really wanted to hit that aerospace class 3 soldering, and it was just so impossible to get it with the lead-free solder that Dan made the decision that we would maybe have to handle a little bit more dangerous material, but the quality of the connection is just far superior, and if there is a small problem, it's very easy for us to correct by hand.
So we wanted to just cover some features on this pendulum. You guys, I think, are familiar with most of them, how to do this stuff, but just in case you're not, and it's similar to the C2 also. So if you got, and the Momentum integrated too. So anything that you might not have read the user manual for, Bill thinks you guys never read the user manual, and I'm like, I don't know if they do. And he goes, well, why do they ask us all the same question all the time? And I was like, that's a good point. So this one has the phono module in it, and it also has the DAC streamer in here. And I'm probably going to repeat it, which you guys already know, but maybe not. If you want to change something on the phono cartridge, just take the 2 little screws out, pop this little guy out, and you can change it. If you have an analog unit and you want to get it, it's really easy to install. Just plug it in, it takes 5 minutes. Same with the streamer board. You guys know these are module, right? So you don't need to, you can get it analog or just phono or whatever configuration you want. If you get the streamer, there is an Ethernet port, HDMI, and the optical, right? For the Ethernet, if you don't want to use the Ethernet, you can set it up on the Wi-Fi. And the way you do it is go to the remote, go to settings, and then scroll all the way to system, and then click on the Wi-Fi. And when you do that, it's going to be like, if you ever set up like a smart bulb or something like that, it makes that kind of like auxiliary network for a second, and then you jump it to your main one. It's the same way, and then it's on the Wi-Fi. If you want to use the HDMI to do a TV, it should link to the TV. Every TV kind of has their own code now, so if it doesn't hook up to the TV, just go to HDMI, and there's a drop-down box, and there's HDMI 1, 2, 3, 4, and just whatever one you have it on the TV, just change it to that, and it'll find that one. I'm gonna go back out of here. Most of the features are in.
Customers who buy this have any problems kind of getting into these nested menus and working around them, and they call up because they have problems, or is it pretty self-explanatory?
No, I think it's a lot of times it's like, oh, it's not connecting to the Wi-Fi or something like that. And it does have problems with like a mesh network where it's constantly trying to find it, and I think it gets kind of tricked up on it. It does have some of the usual business, you know, there's balance, inverted. The headphones, if you want to do the headphones, it doesn't just take over if you plug in the headphones. So you plug in the headphone, and then you've got to activate the headphone on here. And then when you're done, or if you want to go back, you don't have to unplug your headphones, you just switch it off. Dark mode takes a few seconds, I think it's about like 7-8 seconds, and then she'll pop off. And then there's like the brightness, you control brightness on the remote, and then you can do on the meter itself.
So anyway, let me explain to the building structure of the Momentum Z. It's 2 floor, 2 levels. This level has the transformer contribution. The another level, top level, it is only audio section. So if you remember, this amplifier makes 500 watts, actually 550, 500 watts 8 ohm, 1100 4 ohm, 2 kilowatt at 2 ohm. Very strong. And then you need to have powerful transformer. Every single transformer 1 kilowatt. And over total, plus and minus, it is providing you 2 kilowatt power without loss. So we have the special distribution PCB inside. I am going to mention you why it is special, but before explaining to you this one, let me explain to you the we added breaker switch. All the old Momentum, it doesn't have the breaker switch. This one has it. Why this one has it? Because the system is more powerful now. And the Ethernet connectors on the power chassis and your speaker terminals on the power chassis. And if we come to the top channel, we are using 22 micron gold connectors. That are the golds. Why? Because the fast delivery, fast and without losing delivery, the power delivery. This is very special connectors, 22 micron gold. And in this structure on the top here, it looks like aluminum, but it is not aluminum. It is 99.9% copper. Yeah, and cadmium plating. Really? And yes, if you touch it, it is really cold. It's really cold because you have to cool your IGBT system with the copper. That's why we are using this side as a copper. And then so we drop the copper inside. It is the 0.25 inch thickness, and then we drop, and then we are use the bolts, and then holding the structure inside. And then if you see here, there is a 1, 2, 3, 4 copper standoffs. Those standoffs getting the whole ground system from the power supply board. This one, whole grounding system. We are using the whole chassis as a ground. This is special. It is like a very special system. And
yeah, I mean, you ground on your
exactly
just to the chassis. There
exactly,
really
exactly. Your audio chassis, it is getting the ground from the chassis. And when we come to this structure, if you look to the screen, Dan D'Agostino mentioned we didn't use like a piece of plastic to just to show the levels. We used the real high resolution, the real screen. It shows you very nice. It is extremely high resolution. It is here. I can show it to you. Here. This is the high resolution special LCD screen. We use as the background, and then so when you turn it on the amplifier, all the numbers comes. The meter is calibrating itself. All the DC level, bias level, temperature level, all the check marks you can see on the system. It is more than a display. So and so of course you need the feeding system for this display and digital sites inside the amplifier, because we have some controllers and digital control plus and minus start from this point. The system is getting AC voltage. Your AC voltage getting regulated from this point. It comes from this protection 15 amp fuses, and this is the extra protection inside, and it goes to your IGBTs. So in here, every single regulation system has their own controller boards, right and left channel, right and left channel. This one, it is the main controller of the system. DC level, bias level, temperature level, all the levels control with this board. And this board also controls right and the left controller as well. This is the main brain of the system. In here, when we come to this section, this is our analog regulator for the input boards, special input board, JFET input boards, and then our positive and negative voltage, we are having from those regulators. If you look at the system, we use the special bus bars. Those are the copper cadmium plating, and then so our high rail voltages, plus and minus, we are delivery with those bus bars to the output. If you look here, like this thermal sill pads, this is the very special thermal sill pads. One big aerospace company providing to us. They are making for us. They cut the special custom design, and then they are making for Momentum Z. It is, if you touch it, it's really cold. Touch it, it's really cold.
It's not plugged in, is it?
No, it's not.
Yeah.
No, you are fine. You
And by
will
the
fine.
way, guys, if one of these fuses blows, your amp's broken. Don't put a new fuse in.
Is this the switch you were talking about to change the impedance?
Yeah.
Yeah.
Yeah, and then so this is the buffer on, buffer off. It's this one is the this one is the Z. This one is the Z input. This one is the regular input.
So when we made it easy, you take 2 screws and you slide the cover, put it back.
Yeah, it is super easy. It's sliding in out, and so. If you look like we use here like little switches here, we made only one board, and then we are ruling the board. Hey, you are the right section, you are the left section. If you make the switch combination, and then the board says, oh, I am the right side, I am going to, to provide the right side voltages, and then other says, oh, I am going to provide the left side voltages. That's why like they're the little switches, but exactly same board, and then super clean. The very like a building instruction is very easy. We have our own app, the Agostino application. Every single member has the iPad, their username, password. They are coming here. They are building their like system. Right now the internet is little slow. The system is the loading a little bit slow, but all the structures are here. The builders, production line engineer, production manager, technicians, quality control guys, and shipper and the sales people. They have their own account, own iPads, and then everybody track each other.
Could you offer this as a Heath kit so you can build it yourself at home? Can you do that?
If you have this one, you can build it. If you have this one, you can build
it. How much money would you save by selling it as a kit? People who would,
yeah, and then we can give you one iPad, and so you can.
Sounds easy.
Yeah, you can do it. So okay, it is coming. Right now, if you look here, the JS audio, we put it here, the JS audio. JS audio, like my builders are working on the JS audio order, and then the JS audio give the order, and then they are looking the work steps, if there is any requirements, and if anything here. So it is here, the JS audio.
Who developed all this software?
We did it. We internal team, we develop it. We have the computer engineers. They develop they develop a system from us, and right now, and then so my builders, they open their application, and then they are looking, oh, JS Audio give us an order, and then they start, okay, let me start it, and then he collect all the materials, bring his table, they start to put together, and then JS Audio also knows what is the tracking status. Like in the work. Yeah, and then JS Audio, the JS Audio looking, where is my amplifier? Where is my amplifier? It is coming or not? And then he's not calling, hey Burhan, our amplifier is ready or not. He's not calling me. He's looking from the system. I said,
You know what my new excuse going to be?
yeah, I want to.
You pay more attention to the guys that pay up quickly than
And then also look, let me tell you something. It comes, you know, the work status, how many hours he spent, one technician, how many hours spent on his order.
Wow.
When he started, what is the serial number, what is the voltage, JS Audio know the details. Because JS Audio order 10 amplifiers, 10 pair amplifiers.
C001, I like that.
Yeah, and then so they are looking the work information, and then JS Audio location here, and then we are just packing and shipping to them.
With the Momentum C2 preamplifier, the preamplifier has three primary jobs. So volume, input, and output, right? Now some of our products that can consist on a full, dual mono design, right? And what you see in the preamplifier, it's a simplified version of what essentially we did here. So this is the absolute highest expression of what we're trying to achieve here. So everything's broken out, so you have much more real estate inside here. So the same military grade gold connector volume relays exist in here, but obviously we have less of them because this is going to be a left chassis, this is a right chassis, and then you have your power supply over there. And then also there's a digital element to this particular product as well. So you see the modular hole on the back of the power supply. So that has the access and the ability to add a modular DAC if someone wanted to. But obviously at this level, when people are breaking out all the jobs, most people are typically getting a dedicated source, digital source for these types of jobs. And then what we're going to be seeing here is that you see right here is that we have the completed volume assembly on this black Relentless preamplifier. We're going to be breaking apart the volume assembly back here with Jesus as he's disassembling, because we really want to show the amount of time and energy and effort, but also the engineering that goes behind this and the extreme tight tolerances. Each one of our volume assemblies has more than 100 parts to it that you're going to see. So the way that we're going to break this down is that it's all going to be broken out almost like a watchmaker, but what it takes to build a Relentless preamplifier is minimum just the assembly. We're not talking about the boards, we're not talking about the testing. It's about a week or more. We only have 2 people in the building that we really have that focuses on the assembly of the Relentless preamplifier, because a lot of it comes down to the repetitive nature, but it's also the human touch and the human feel. We're going to touch a little bit about that, because even the bearings that go into the Relentless volume control, the feel, it's all human calibrated. So we actually apply the grease to ensure that the viscosity is consistent across both volume controls. So there's a lot of time, a lot of energy, but that's what it takes to get the job right. Disassembled, so you can just feel the mass on that and the amount of weight because of all those components and the way it fits together.
I'll trust you. I'm not going to pick it up.
But like I said, those dual bearings, we have to basically calibrate those by putting, hand applying the grease, spinning it, feeling it, heating it up.
Yeah. Do you compare it to like a master one that you have set aside?
No, these guys just know how it feels.
Component here is the last one, right? Yeah. So you guys already saw the boards. These are also put together here along with all the wire assemblies. We put these all together as well. And all we're going to do is put this inside of this what we call a meter blind, and it looks kind of like the Incredible symbol, but this is a little bit like the 1600s and 800s in the way that the LEDs are actually facing inwards towards the meter movement itself and towards the meter display. So you see, like on the Relentless, you'll see kind of that halo effect. This looks a lot different than the M400s and the progression amps. So they wanted to obviously make sure that this has the same kind of design, but we're going with the meter plate. And then this one just looks like a kind of speedometer to a car. We have the red line here. We're going with that. And then this is the meter housing. Anybody guess what that does? Houses the meter. Yes. Good job.
You're killing it, man. You're killing it.
Yeah. I was told there'd be a test. I got it blown up.
Do car work too?
I do, yeah, I do. I have some projects that I work on myself, yeah.
Me too.
What do you have?
Well, I used to work on an old Saab. I rebuilt the engine. packed wheel bearings, brakes, clutch job. I had to give it up though.
It's expensive.
I had to give it. I had a handful of grease, then I go outside and put a $10,000 cartridge in. It just became.
Yeah. So here we have the first kind of step of it. Now we're going to put in what is the most delicate piece of this. It is the meter movement itself. So I don't know if you guys can see, there's a little coil on there. There's that same coil that's on the back. It's the same thing that's on the front. There's two different coils, and they're just really there for us to calibrate and make adjustments as necessary on these meter movements. They're extremely sensitive, much like a lot of the watches you guys are wearing. They're just have very sensitive movements inside of them. So they have to get kind of slotted in a certain way in order to avoid hitting that meter wand on some crucial components.
Where's the meter movement built?
I'm not sure. Yeah, they're outsourced. Like we bring them in, but they build them to our specifications.
Right.
Like this is like a one-off thing. We get them down to 0.05% tolerances, and that's where we still have to make adjustments then, because even then it's not perfect.
Gotcha.
So we have to make adjustments ourselves on those. And then these set screws that are going in, this is just in order to help us kind of align the meter movement and aligns the circuit board that we're about to put onto it. It's not really part of holding anything down, it's just in order to keep things where they need to be. And then the same thing can be said for these Phillips screws. We chose these ones specifically just because they have the concave, and obviously they're going to sit inside that screw, and it kind of helps align the board as you kind of tighten it down. As you notice, whenever I tighten it, it kind of shifts the board into position of where it needs to go.
Are you doing this more quickly than you would do it if you were?
Yes.
Oh yeah, absolutely.
Yeah, we're honestly we've been running out of time on these, but yeah, it's going together. And like Josh mentioned, throughout this assembly process, there's parts where I need to go and test things, and I need to make calibrations in order to make sure that they're up to spec.
So what is the real time in making one of these?
Talking about the preamp or the volume control?
Just the volume.
The volume controls probably 3 hours for one.
So there's two of them.
And then we have to do two of them. Yeah, because like I showed you guys that LED board, we make those. We put the connectors on the end of them. These boards we make ourselves also.
And when you do this for real, you're sitting down, you're not standing up.
No, we are still standing up. Yeah. When there's certain parts like I'm going to talk about right now with the soldering that we do go and sit down at this actual soldering station. So right here, you guys can see a little silver tab that's there, and that's where our ground is coming from. That's our reference point for the ground for the meter movement itself. And then up at this top tab, so this is where we solder, and that's where the voltage goes to, and that's where it kind of, depending on the voltage that's coming in, that's where it tells the meter how much it needs to move up. And that just gets soldered here. So the ground jumper will get soldered to this point, and then the live one will get soldered over to this point. So that's kind of the soldering there. And then from this point is where we take it over and make adjustments to set the zeros and to make sure that it's moving accordingly before you put the whole assembly together and then realize that the meter itself was 1% instead of 0.5%, something like that. So we'll take this meter shaft now, and then this meter shaft is very crucial to the alignment of it, only because of the hat that's this sitting here. It works in parallel with this, and it just it has to be to the really tight tolerances that Josh was talking about.
Are the machine shops that make these aluminum parts local?
Yeah, we have a couple of suppliers, but a lot of our stuff comes out of Colorado. Yeah.
All right, and then now that we have this kind of assembly, that's kind of stage one of this full assembly. There's kind of really just two major parts, and then we're going to move on to the larger volume control assembly. So we slide over these bearings, like Josh was telling you guys. These are bearings that we adjust, and we apply the grease here. And then we take the bearing spacer, and all this is doing is that as we tighten this, it keeps the bearing faces in alignment. So if with ball bearings, if they'll start to bow in one way or another if you're tightening them, and that kind of throws the ball bearings themselves out of alignment, and that's not good. They'll start to bind or seize up.
Yeah. It's when you start to feel some of that drag on the volume control.
And then we'll come in with this encoder disc that works with this encoder reader. And these are all military spec components. And then we just go in with another nut that this is just a retainer. We're not trying to put a lot of pressure on this. It's a tiny little plastic disc that's here. You don't need a lot of pressure on this, but it's just to keep it from moving. And it really this doesn't ever come into contact with any other component on this. It just sits inside of this reader, and that's how it tells it how many relays to open within the unit. So now that we have this kind of stage 2, we'll take this component here, and then we'll just slide this one over the top. And then this is where the alignment piece comes into play, because right now I can wiggle it and it's hitting the walls, and all this is doing is just helping to keep everything where it needs to be. And then just like a tire, when you guys are tightening down, we're moving across to keep everything flush. The bad thing about having extremely tight tolerances is that things will bind up sometimes when they're not perfectly aligned, and that's just what we're trying to prevent with this process. So you guys can feel the sheer weight of this.
I don't think I did this station for some reason.
You haven't?
No, can you do, I think I'm the only one that's here. Can you do this just for me? I'm a very important person.
Yeah, no,
and very modest too.
I'll talk to you later. Okay?
So let's put that
Go
right
ahead.
there.
I'll show you that, like, basically 3 types of boards.
So what is the job, what is it that you're showing?
So before anything gets stuffed, right,
Yeah.
what we'll do is we'll do a pre-inspection. And the pre-inspection is basically to catch any defects, especially if it's a raw board coming from a manufacturer or an SMT board that's already been populated, or even something that comes off of the wave machine that's been populated as well. So these are the things that, you know, I'll show you real quick. But perfect example would be this board. I've given it to a couple people here to see if they could find any mistakes.
Yeah.
And a lot of them they can't find it, obviously, because it's, you know.
So I can find a mistake on this?
If you can find it, I'll give you a Diet Coke.
Oh my God. So look this. Okay, I see one thing.
Okay.
Hold this board because I'll show. I see something right there. Is that it? Then or
Let's take a look. Where is it? Oh, there we go. There it is. Yeah. That actually wasn't the mistake, but you're the first person who's caught another mistake.
How's that? Is that good?
That's great.
So what do I get from doing that?
A Diet Coke. Or a Coke, or regular Coke, whatever you like.
Some Coke. Yeah. So where's the other mistake?
Right there.
Everybody at home, are you impressed that I found that?
I am very impressed.
I'm talking to the people at home that are watching this. Oh, I'm breaking the board.
Yeah, so, and we can tell that this happened outside of our facility. This happened at the manufacturing facility of the board, because there's masking over it. There's blue masking over it. It could technically pass. Do you see that itty bitty connection right there?
Yeah.
It could technically pass, but we don't want that.
No, you don't.
So what we'll do in this case with this board gets completely scrapped.
Yeah, I would think so.
We'd put that aside. But then we also want to be able to check our SMT stuff, because mistakes happen. These are populated. So we always want to make sure.
Now, who stuffs the boards? There's a place that does this in some other
yeah, it would be at another location.
Where is that? You know?
I cannot disclose that.
Okay. I've been to board stuffing places, so it's just interesting.
There's multiple, yeah. But we try to stick on a lot of the stuff. We try to stick to local.
Yeah.
And we try to like support local businesses as well.
Good idea.
Yeah. So right there.
That's another.
Yeah. So that's a crack on the joint.
Oh yeah, look at that.
So as you can see, it is making contact with the pad, but it doesn't matter. Like you can't use that, because what will happen is if you put that in a unit, it ships. There's vibration. You put it in a cargo plane. There's vibration. Hot, cold, hot, cold.
Of course.
It'll destroy it. And we can't use
your
that.
job is to find all this stuff.
Not just mine, but everybody's.
Everybody's.
Yeah, everybody's.
That's a big responsibility.
It is.
Once something's finished and goes out like that, it's not a good thing.
No.
If something happens. And even if something doesn't happen, will it affect performance on some level?
We tried to not move the board past that point. If it's cracked, we put it aside. If there's something wrong with it, we put it aside.
Yeah.
But here's another one. This is coming off the wave. So you can see we tape off some of the finer pitch stuff.
Right.
Because this does require more intricate soldering techniques. So we'll go in here. Right there. You see the bridge?
That?
Yep. So that's a bridge. So that'll cause a direct short in the board. So if it gets to the jig station, it'll essentially blow up.
Yeah.
Yeah, no, it's not.
No, we don't want that.
There's another one.
Where is it? Oh yeah.
There's a pinhole in it. And these are easily repairable. Again, we put some solder wick on that connector.
Yeah.
We go ahead and fill it in with a little bit more solder. And it's pretty easily repairable. We don't try to worry about that too much, but we always catch it and fix it. A lot of the things that we look for is it's in the joints. A perfect joint is a triangle or a little volcano.
Yeah.
So we'll go through and make sure that they're all looking similar.
These are all produced in the wave thing.
Correct. This board has been passed through the wave. Yeah, and a lot of mostly everything that we do through hole is passed through the wave. But you can see right there how it's like a divot almost.
Yep.
We would touch that up because we don't want that type of stuff.
And so every board that comes out has to be looked at like this.
Correct. Raw, populated, wave. It has
and using the microscope.
Using the microscope. Correct.
Wow, that's a lot.
And you'll see one of our other board builders has a microscope at her station, and she's usually responsible for the finer pitch soldering stuff. But from here, once the board is fully built, it'll be on a rack, and then Rob.
Can we just walk over there and look at that?
Yeah, we'll come over here and look at it.
You can't do it too long before you burn out. You have to change to a different job.
Correct. That's why we do have multiple people on it. But you know, once those are done, it'll come to this area. So basically, we don't put a board on here unless it's been checked, right? So it is populated, it's been checked, and there's sign-offs to that type of stuff. But once it gets to this stage, what'll happen is Rob, our main wave guy, and some of the techs will grab the boards before they get into the unit, and we'll head over to this station real quick.
This is what's annoying when I deal with consumers who look at products and go, well, I know what the parts cost of that thing, and this is, and they just don't get what goes into all of this QC and all of this making it perfect, and the time consuming and labor consuming. It's
very intricate, and not everybody can do it, honestly. No. It takes a very particular type of person to do it.
What's the training period for these kinds of jobs?
Well, normally what we'll do is we'll start people off by stuffing a board, and they have to be able to know how to solder. JSTD certification is always appreciated, and that's usually just the standards that most companies use to make sure that they know how to solder, and cable assemblies as well. And usually you would go maybe 3 to 6 months before they even start checking boards.
And do you have a period of time where you let these people actually hear what they're building so they can hear it?
Yeah, they hear it every day.
That's good.
Yeah, no, yeah. I had someone ask me how much D'Agostino I have at home, and I'm like, I have it for free here. I get to listen to it for every day.
That's funny because I once had to talk to the head cellist of the Berlin Philharmonic, and I said to him, so what music do you listen to at home? He goes, I don't listen to music at home. I do it at work during the day, and I'm too tired to do it.
Oh my gosh.
I don't want to hear music anymore.
This place definitely makes you appreciate music a little differently, for sure.
I know.
But I'll walk you over to our jig station, and I'll show you this part too. So those boards that were on that rack will come over here. And I like to always tell people, like, this is not pretty, but it's functional.
Yeah.
And this is what we care about, is the functionality of things at this stage. So essentially what this is this is a C2 jig, and you can test 2 banks of boards. And you can also use this for the Momentum integrated as well, that Momentum integrated MXV. We have our S250 and 400, 800 progression, Relentless Preamp. And this one, we have it stacked up, but we have to put it on its side. We have to have special cables running to it because it's a beast. And then
I had one at home for a while.
Yeah.
It's so good.
Yeah. And then we have towards the back.
It looks small here, but it's so big in my house.
Oh yeah. But towards the back we have the 1600 jig. We have that on a special cart because we can't.
That's a big amp.
We can't put it on a table. It's too massive. So we keep that isolated. But I'll walk you through, and you can get to see all the numbers real quick.
Let's do that.
Okay.
Hope you're enjoying this. I'm enjoying.
Oh no, I don't mind at all.
I'm enjoying it.
So what we do is we check for 4 things in particular. We'll check for distortion. We'll check for our gain. and we'll check for our sine wave. And we'll do that through every input as well, just to make sure everything's good. These are all based on numbers that the engineers give us, make sure that they're within that range. So what we'll do is, with this right here, we'll go ahead and turn this on.
And this is the C2 jig?
This is a C2 jig, correct.
And which is the C2? That's a smaller preamp, smaller than the Relentless?
Correct. It's the one right in between. So
I heard it's close.
It sounds pretty great. So we'll turn it on, and you're looking for a smooth sine wave. You're not looking for clipping. You're not looking for square wave, sawtooth, all that. So we'll increase the volume. You can hear the mechanical relays clicking. It's perfect.
Yeah.
Right. We'll come over here. We'll look at our distortion. That's our distortion number. That's our gain number. And then we also check our noise. Negative 92 dB.
That's pretty good.
Yeah, that's pretty good. So if you put your ear by a pair of speakers, like around the tweeter area, you won't hear a thing.
There's more noise coming from my ear at this point.
But yeah, I mean, and this will be done through every single board, every single product. And what we try to replicate is client use. We have loads hooked up as well, so our loads will mimic a speaker. And we'll go ahead and connect that to our amplifiers, our integrated, and we really try to replicate what it's going to be doing in the field.
So this is one channel of the preamp here?
This is one preamp.
One whole preamp.
Yeah, and this is, the channels are broken up into sections. So you have left channel and you have right channel.
And then once all of this passes, these boards go into a place where it said this is all the boards for this particular build?
Correct. So these units would be signed off. We have 3 stages of signing off. So it'd be the person who builds it, the person who checks it, and then they circle their initials, the person who tested it. So they'll have their initials and the underline. An assembler is already trained and taught that if it doesn't have those 3 signatures on there, they can't put it in a unit.
And I understand you're going to make this available as a Heath kit next year? No?
I don't know about that.
You think I can sneak this under my coat? Okay, this one's passed. This is all passed. So this is a Relentless. I wish I could afford this, but I can't afford this. This is really good. All right, that's that. And out there you see the stuff being shipped out. And so they've got a taco truck here. And like we ate so much last night that I don't even think I'm hungry anymore. And then they have your fixins are here, and the fixins are like you build it yourself, like the people building the amplifiers. And you build it yourself. God, you're eating again. I just can't believe that.
I know. After last night, I didn't think I'd be able to.
Yeah, and you're not even having a sampling. You're just having a full.
I mean, this
plate.
is what they give you. You know, you get one in Rome.
Yeah, I know. Like last.
Please continue. Yeah.